In December 2015, representatives from 195 countries gathered in Paris for what would become one of the most significant agreements in modern history. For the first time, nearly every nation on Earth signed a legally binding commitment to limit global warming, the target. Keep temperature rise below 2 degrees Celsius, ideally 1.5 degrees Celsius, compared to pre-industrial levels. But what does that actually require? To hit that target, the world needed to cut carbon emissions roughly in half by 2030, now that's right around the corner, and reach net zero by 2050. That meant one thing: phasing out fossil fuels from energy, transport, and industry, and enforcing all of this by law. And so the shift began. Countries started setting deadlines to ban combustion engines. Investments in solar and wind exploded. Entire industries started rewriting their future. But here's what the Paris Agreement never mentioned. What nobody talked about in those conference rooms is what all of this actually runs on. Because you can build all the solar panels and wind turbines you want. But the sun doesn't always shine. The wind doesn't always blow. And electric cars need to store energy somehow. The answer to all of it is the same: batteries. And that's where the real story begins. So, what actually is a battery? At its core, a battery is a device that stores chemical energy and converts it into electricity. Simple. You have three key components: a cathode, an anode, and an electrolyte in between. Almost every battery works like this. The most used batteries today are the lithium-ion batteries. They use lithium ions as a base. And what is key is their cathodes, because the cathode material is what defines the battery's chemistry, its cost, its performance, and its range. When we talk about battery types, we're really talking about cathode recipes. The three main ones in use today each make a different trade-off. NMC, nickel, manganese, and cobalt, is the king of the EV market. High energy density means more range per charge. It is the choice for most European and Korean manufacturers like Volkswagen, BMW, and LG Energy Solution. LFP, lithium, iron, and phosphate, plays a different game. No cobalt, lower cost, longer lifespan, and inherently safer chemistry. BYD built their empire on it, and even Tesla has shifted their standard range vehicles to LFP. It's also becoming the dominant chemistry for grid-scale energy storage, where cost matters more than weight. NCA, nickel, cobalt, and aluminum, has the highest energy density of any lithium chemistry, but also the most expensive and the hardest to produce. Today, it's retreating to niche applications where maximum energy in minimum weight justifies the cost. There are four materials that are true strategic assets in the battery market. Lithium is the foundation. Every lithium battery, regardless of chemistry or type, needs it. It is the working ion the entire system is built around, and there is currently no viable substitute. The world's lithium is concentrated in three countries: Chile, Argentina, and Bolivia, a region known as the Lithium Triangle, which sits on more than half of the planet's known reserves. Australia is the other major producer, leading in hard rock mining. Between these four countries, they control the vast majority of global supply. Cobalt is the controversial one, key to extending battery life, and for years it was considered indispensable. The industry has been trying to reduce its dependence for a decade using nickel, but hasn't fully succeeded yet. Around 70% of the world's cobalt comes from a single country, the Democratic Republic of Congo. That concentration alone makes it strategically sensitive, but we also have to consider reports of dangerous working conditions, child labor, and communities bearing environmental costs with little benefit. It is the material that forced the battery industry to confront its ethical contradictions. Nickel. The more nickel in your cathode, the more energy you can store. As the industry pushes toward higher performance batteries reducing cobalt, nickel demand is exploding. It is quietly becoming the most strategically contested material in the entire supply chain. Indonesia holds the world's largest nickel reserves and has rapidly become the dominant supplier, accounting for over 40% of global production. But Indonesia made a bold move in 2020, banning raw nickel ore exports, forcing manufacturers to refine locally rather than simply ship raw material abroad. which complicates the supply chain. The Philippines and Russia are other major producers, though Russian supply has become increasingly unreliable for Western manufacturers because of the sanctions. Graphite. Almost nobody talks about it, but it makes up the anode in virtually every lithium battery ever made. It is as critical as any material on this list. Graphite is abundant, but its manufacturing process is not. China controls approximately 65 to 70% of natural graphite mining, and over 80% of the global processing and refining capacity needed to turn raw graphite into battery-grade material. With this leverage, China restricted graphite exports as a competition policy. Graphite is the one where Western supply chains are most dangerously exposed. If this level of analysis brings you value, join the strategy by subscribing to the channel. We decode the global markets using visual economics that the mainstream media often ignores. Let's get back to the breakdown. The green transition was supposed to be about leaving geopolitics behind. Instead, it created a new kind of resource competition. The shift from oil to batteries doesn't end resource dependency, it relocates it. From the Middle East to the Congo, Indonesia, and Chile. From petrostates to battery states. The clear dominator of the battery market is China, and its position didn't happen by accident. While the United States and Europe were focused on software, finance, and services, China made a different bet, that the future of the global economy would run on physical technology. Batteries, solar panels, electric motors. It moved early, moved fast, and at every level of the supply chain simultaneously. It starts at the ground. China secured mining stakes in the DRC for cobalt, in Australia for lithium, and built processing facilities in Indonesia for nickel. On top of that, today China refines roughly 80% of the world's battery-grade lithium, 65% of cobalt, and over 80% of graphite. Raw materials extracted in Africa and South America routinely pass through China before becoming battery components. And at the end of the chain, two companies define the industry. CATL, the world's largest battery manufacturer, with 37% of the global market, supplying Tesla, Volkswagen, and BMW, and BYD, which in 2025 overtook Tesla as the world's largest EV seller by volume, at prices Western manufacturers simply cannot match. China didn't just join the battery race, it built the track. The response from the US came from the Inflation Reduction Act, a massive package of subsidies designed to rebuild domestic manufacturing. Billions of dollars are now flowing into gigafactories across states like Texas, Nevada, and Georgia. Companies like Tesla, Panasonic, and LG Energy Solution are racing to localize production, but it still depends heavily on foreign sources for critical minerals. America is trying to reshore industry without fully controlling the inputs. Europe faces a similar dilemma, but with even higher stakes. The European Union has pushed aggressive climate targets, effectively mandating the transition to electric vehicles, all starting with the Paris Conference in 2015. But when it comes to batteries, Europe started late. To catch up, the EU launched the European Battery Alliance, aiming to build a homegrown supply chain. Companies like Northvolt have emerged as flagship projects, backed by governments and automakers like Volkswagen. Even so, the problem persists. European factories still depend on Chinese processed materials, meaning independence is partial at best. Then there are the battery states that hold the raw materials at the foundation of the entire system. Some, like Indonesia, took the most aggressive route, restricting raw nickel exports to force companies to refine and build industry inside their borders. Others, like Bolivia, chose control, nationalizing lithium and limiting foreign participation in an effort to capture more value. And then there's the Democratic Republic of the Congo, home to most of the world's cobalt, trying to escape the just mining trap, but still largely stuck at the lowest value end of the supply chain. Today, the battery market is no longer emerging. It's scaling at an unprecedented pace. Global demand has already crossed the 1 terawatt-hour milestone, driven mostly by electric vehicles, which account for the vast majority of battery use. But growth is no longer smooth. Recent data shows the market is starting to slow down as EV demand fluctuates and oversupply hits key materials like lithium and nickel. At the same time, prices are falling, technologies are shifting, and competition is intensifying. Looking forward, the direction is clear, but not simple. Battery demand is expected to triple again by 2030, surpassing 3 terawatt hours, as electric vehicles, trucks, and energy storage systems expand globally. New technologies are reshaping the market. Cheaper chemistries like LFP are replacing expensive materials, and recycling is expected to become a critical part of the supply chain due to the limitations on raw materials and increased demand. China is expected to remain dominant, but its share will decline as the US, Europe, and emerging markets expand their own capacity. The battery market isn't just growing, it's entering a new phase. Not a race to build capacity, but a race to control cost, technology, and all the strategic assets of the market.